Thank you. Thanks again for your patience for those little pauses. There'll be a big payoff over the next 50 years in terms of editing. Obviously, one of the big benefits of the open web platform that we've been discussing today is the ability to develop apps that run on and connect a wide diversity of devices, from desktops to tablets to mobiles to televisions. We'll hear next from Rajesh Lal on designing apps for the mobile and TV world. Rajesh is an author of books on widgets, gadgets, and mobile development. He's a senior engineer and developer evangelist at Nokia. I'd like to thank Nokia again for their support for the conference. And please welcome Rajesh Lal. Thank you.
Thank you. Good afternoon. The end screens problem. The end screens problem is a set of challenges which you will come across if you are developing an app for multiple connected devices. And today, I'm going to talk about some of the contextual problems, some of the challenges, some of the solutions, some of the workarounds which can be applied to these problems. This is my plan for the next 30 minutes. The first thing I'm going to do is talk about the end screens, the devices, the multiple connected devices I'm talking about. Then I'll go into the design challenges. The design challenges are basically the contextual problems which you face when you try to develop an app for multiple devices. Then I'm going to talk about the choices you have for development and why a web app is a better choice, and we'll talk about some of the history of the web app, how we came to a web app. And then finally, I'm going to talk about the implementation challenge, which is the 7 key implementation challenges which you will face when you are trying to create an app for multiple devices, and also the workaround for those challenges. So the session is not just about problems, it's also about some solutions. So these are the 4 screens I'm talking about today. A mobile, a smartphone with a very advanced browser, a personal computer, a tablet device, and a internet-connected TV. So the first thing I want to give you is a context on which these devices are used. And when you're creating an app for these devices, you should start from the design problem. So the design problem is the challenge, the challenge of these devices, how they live in a particular context. So this is the first device, mobile phone. So a mobile phone has a very small screen size. It has from the eye, it is distance of 1 feet. It has a connection, 3G connection, not very reliable, and the user is highly interruptible, and it has a finger input. So it can be a virtual keyboard, it can be a physical keyboard, and the user is on the go. So the most important aspect of an app for mobile phone is the user is in a dynamic environment. The second one is the tablet. So when you're creating an app for tablet, you should understand that the user is in a more casual environment. The screen size is a bit bigger than a smartphone. Distance is almost the same. It might be connected with Wi-Fi. The user is still interruptible, and the input is touch. The third one is the PC. So with a personal computer, I think the most important aspect of personal computer is user is very focused. The input of a personal computer is very accurate, keyboard, mouse, it's like pixel perfect. So the app you create for a PC can be completely different from an app which you create for a mobile phone. And last of all, the TV. So TV is also a more casual environment, but the focus of the user is much bigger here. The user is, the target is of total immersion. So when you're watching a TV, you don't want to get interrupted at all. If something interrupts the user, he actually pauses the TV and then resumes the TV when the work is done. So you have to understand that you don't do that with a PC. You don't pause your application on a PC when you are interrupted, or you don't do that in a mobile phone or even a tablet. So that is the contextual problems you'll face when you are creating an app for these devices. The next set of problems I'm going to discuss is basically the choices. The choices we have when you want to develop an application for these devices. So of course, there are two choices. There's a native application development environment. Each of these devices comes with its own SDK. It's great for that particular device. It's very reliable. It's very robust. It has a set of APIs for that particular device. But there is also some negative aspect to it. There's a learning curve for each SDK. You have to learn multiple programming languages. You need time and effort for every device, maintenance, version. So the solution is robust, but it's not scalable. If you want to create an app in a native programming language for 5 different devices, you have to multiply your time and effort into 5, plus all the maintenance and the versions. So the web app solution is the solution which I think is the positive story for developers. It's the step in the right direction. And HTML5 is the engine behind the web app solution. Very few of the people know that the original specification of HTML5 was known as Web Application 1.0. So it was meant to create web applications. So what is a web app? Web app is basically an application created using standard web technologies. And there can be 2 types of web app. An application which is on a web browser, possibly a full screen web browser. And then the second kind of app is the same application which is rendered using a web browser, but inside a native container, which is also called a hybrid application. So here you use the same technologies, but you have a native container which is wrapped around your web app, and which allows you to distribute your web app more easily. So before we move into technical challenges, let's take a look at the history of web app. So I'm not going to go into details of each of them, but it all started with the HTML, right? You have some basic tags. Then there was a time when web applications were like the dominant internet-based applications. Then the third stage was, I think, the whole web applications evolved into rich internet applications like media players, plugins, Flash, Silverlight. And then for the time being, that was a very good solution, audio, video. They has its own private storage. And then based on all these requirements, HTML5 came up with all the advanced tags, which was the need of the hour. So there is Canvas, Media, and all these advanced APIs. And simultaneously, there was also a mobile revolution going on, which needed the user to create apps with the device APIs, like touch. You need a mobile touch user interface in a mobile device. You need API for camera access, calendar notification. So this whole HTML5 with all these device APIs created a new set of applications, which can be called as a web app. So the pros of a web app is one SDK, easy to develop, powerful HTML5, CSS3, and there are some cons. So the first thing is it's work in progress. So if you think about a web app environment supporting so many different devices, I think it can be safely said to be work in progress forever. So and then there are challenges when you port these apps into many of these screens, which I'm going to talk next. So although the story is very promising, HTML5 with web app has a lot of potential, but there still are some challenges, and we'll see that in the next session, next topic. So what I'm going to do is I'm going to show you 7 key challenges which you will come across when you start creating your app for these multiple set of devices, and of course how to work around them. Okay, so the first challenge is the feature detection. You have these number of devices. You open a web app on your device. So you have all these advanced HTML5 APIs, HTML5 tags, but what all features are actually supported by that particular device? The older way of doing this was you start with browser detection, and then based on each of the browsers, you assume the functionality will be there. I think that is the way, the older way, but the newer way is basically you detect a particular feature, detect a particular API, whether it is available on your device, and then implement your function. So how do you do that? There are very simple ways to do that. First one is by using plain JavaScript. You can say detect my HTML5 element. If the element is there, return true or false. Another way is using these JavaScript libraries. And I have to mention Modernizer, one of the best libraries available for feature detection today. And there is a session tomorrow on Modernizer. I would recommend everybody to attend that. And then, of course, there is a jQuery library which comes with a support object, which also helps you in these feature detection. So how do you implement that? It's very simple. You include the JavaScript library. You query the property, modernizer.canvas. If it turns out true, you have the canvas element in your device implemented and running. If not, you have no canvas. So it's as simple as it can be. jQuery.support, whether it supports Ajax or not, that's a simple Boolean property. You can query that and you get back a result. Based on your result, you implement your application. And then a lot of these features which comes with Modernizer. So you don't have to worry about whether your device supports SVG, whether they have WebSockets, geolocation, local storage, drag drop. All of these are just Boolean properties. You query them, get back result, and then the same with jQuery support. So these are some of the main challenges when you are creating an app for these connected devices. Does it have Ajax? Does it allow cross-domain resource sharing? Is fixed position allowed? I think fixed position is not allowed in any of the devices. But whether opacity feature of CSS3 is implemented on the device, all these things. So you have a very good way, workaround to detect the features and create your app. So the second thing is layout detection. So you have multiple screens. You have this number of devices. You have number of these screens, all with different resolution, different orientation. How do you create an app which you can cater to all these devices? So these are some of the options you have. You have media queries, which I'm going to talk about next. You need to be concerned about orientation of the device, whether it is in the landscape mode or in a portrait mode. What is a viewport? Viewport is also one of the important elements of layout, which I'm going to discuss. And then, of course, if none of these works, you have the plain JavaScript. So if you see in the ladder, the bottom ladder is your backup plan. It's like the worst case scenario you have is you have JavaScript. So you query window.width, window.height with JavaScript, and you find out if none of these works. But let's see how the other things work. So the first thing is media query. So what are media queries? Media queries are special tags which allows you to include custom style sheets for a particular width, height, color. So if you want to create a style sheet for an app, for a TV, which is 1080p, you can specify your maximum width, minimum width, and say that use this style sheet when the width of your device screen is between this range. So this is how you use it. If you have a single app for multiple devices, you include a style sheet for a mobile phone, a default style sheet, or maybe a wider style sheet for bigger screen. Very simple media queries elements which is supported in HTML5. And if these are not supported, like I said, what is the worst case scenario? So so this is how it will look like. You have the handheld version, you have a default screen, and you have a wider screen. So I'm going to show you later working version of these apps. But what is your worst case scenario? Your worst case scenario is a property of jQuery. So jQuery comes with a feature called jQuery.mediaQuery, which you can include in your application, and then it adds the basic media query support to all the browsers. So this is your default workaround for layout detection. And then there is another element of the media query, which is the device aspect ratio. Sometimes you might need to find out what is the aspect of your TV. Is it 16:9 or 4:3? And based on that, you might be streaming your video. So if the media query is enabled in your browser, you can have your style sheet accordingly based on the device aspect ratio, and then you can create your app. And then the third point I said, orientation. So there is also an orientation tag which comes with CSS3, which goes with the media query. So you can specify the orientation is portrait or landscape, and based on that, you can have your own styles. And also, there is a device orientation event which is in a specification stage at W3C. So there will be a standard event for that whenever you change your device from landscape to portrait. So the last one related to layout is Viewport. Viewport is basically the area of the screen which is your real estate for your web application. So there is a special meta tag which allows you to make that display size of make that real estate of your web application full screen or any width you want. So basically, if your dimension of your device screen is 480 by 640 and your viewport is 360, you can say width is equal to device.width, and it will automatically scale your UI to the device screen. And then you can also scale the viewport to like 2, 3, or 0.75 the way you want it. So very useful tools for your layout detection. The third one is quite it's kind of a challenge, like how to utilize CSS3 for advanced graphics. So I mean, CSS3 is very promising. You have like a lot of these advanced graphics and animation, but right now it's not yet ready. So how do you apply all these advanced graphics in your style sheet? A very crude way of doing it is, so basically all the browsers come with their own prefix: Mozilla, Opera, Microsoft, WebKit. So the crude way of doing it is you include all of them. You have Mozilla border radius if you want to set a radius for a development. You have, but the light at the end of the tunnel is the W3C standard. So eventually, only the last line will survive, and rest of them might just merge into that. So this is a workaround, or you can say the way we can do it now. The fourth challenge is we have all these different options of SVG animation. Canvas allows you to create animation. CSS3, WebGL. So when should I use WebGL? When should I use SVG? what should be the appropriate moment for canvas. So that is one of the challenging question which you might face. So this is the ladder for the challenge. So I think WebGL, in my opinion, is awesome and is at the top because it's not available in all the browsers. So it allows you 3D, but only for a specific number of browsers. CSS3 animation is also fantastic, which you can do with the basic CSS style tags, canvas, and SVG JavaScript. So like I said, this is how you fall back. SVG is mostly supported in all the browsers, so SVG with JavaScript or plain JavaScript animation. That's your fallback plan in animation. So let's just go into a bit deeper into each of these. Okay, what is SVG? SVG is basically vector graphics. It's retained in the memory. It has an object tree. So you actually create, when you create an object in SVG, you have all the elements of SVG available for you to manipulate through DOM. You can style your SVG elements. So it's very powerful. And then how do you check for that? You just say modernizer.svg or modernizer.inline.svg. So when do you use SVG? When you have smaller number of elements and large surface. So like I said, when you're creating an SVG element, you have like access to all the inner elements, the complete tree. So you can manipulate them, access them, and it's much better performant than the other option, which is, so this is how you create an SVG. Simple XML tags. This is a rectangle, this is a circle. Second one is canvas. So canvas comes with two contexts. One is the 2D context, and then the other one is the WebGL. So the context 2D is basically a bitmap drawing area. So you have some JavaScript methods to create rectangles, lines, arc, but it is completely stateless. There is no DOM support. You cannot access individual elements inside the canvas. You can check the support using modernizer.canvas, but it performs better when large number of objects and surface is small. So when you have to draw, redraw a lot of things, and you have a small surface area, you go with canvas. If you have a very big canvas, and if you are drawing, canvas is like drawing pixel by pixel. So you don't want to do that. Even the JavaScript logic you will put to draw in that canvas can become very heavy. So that's not what I will suggest. So the third option is CSS3. CSS3 animation is fantastic. Styles for individual elements. You can have better than JavaScript based animation. So of course, and then in Modernizer you can check CSS transitions or CSS transformation, CSS animation. All these properties are there available, which you check before implementing them. And then the last one. So how do you do that? You have this element. This is really interesting because CSS3 animation is unlike JavaScript animation. You don't have to set like positions of your element after every 1 second and make the animation work. What you do is you create a transition effect, and then you say what is your first location and your last location, and that's it. Your device takes care of the animation. It's very nice and very clean animation with CSS3. If it is available, you should use that. WebGL. So WebGL is the second context which comes with Canvas. This is a Canvas-based 3D implementation. It uses GPU acceleration. So this is, I think, the most awesome thing I have seen in last few months. And it's supported only in a few browsers. So whether it will become a standard or not, that is still a question. You can check modernizer.webgl to see the support. So the next challenge is audio video. And I think the challenging part of audio video is the audio. If you're creating a game or if you're really into some kind of application with audio, the audio tag which comes with HTML5 is very limited. You cannot use it for sound effects. So this is your ladder of choices. You start with a web audio, OpenAL implementation, but it is WebKit specific. So there is a limitation there. You also have audio data, which is supported by Firefox. Fantastic API for audio, but with that limitation. And then I have talked with a number of developers who actually fall back to RIA implementation because they don't have any other option to support all the browsers or all the devices. So you go with a Flash or Silverlight rich internet application for audio. And then finally, if you have like, you cannot do that, even that, then HTML5 audio, or you can just embed a wave in the page. So the sixth challenge, how to use Ajax and do cross-domain call. So I think this is also one of the key question which comes whenever you are creating an app for a device. You will always have a content on the cloud, most of the time, if you are creating an internet connected app. So this is the first thing you need to know, whether Ajax is supported. By Ajax, I mean XMLHttpRequest object is supported or not, or can you do a cross-domain call at all? So this is your fallback scenario. The first one is CORS, so cross-origin resource sharing. This is recommended by W3C, and it's very easy to implement. I'll show you the code in the next slide. And then if you cannot do that, the next option you have is a write a proxy. So you are creating another page and trying to fake the browser to say that you are from that server. And then the third fallback plan is the JSON-P. So JSON-P, you guys might be knowing, is a unique way of using JSON data in a cross-domain environment. So you can, and a lot of these online APIs like Flickr and Yelp, they provide this JSON-P data format. So if you're creating an app for them, if JSON-P is available, that's the way to go. And of course, if other options are not available. And then the last option you have is a hybrid app. So the hybrid app basically gives you this unique capability. Because it's a native application, you don't have that cross-domain problem. So you can just create a container and embed your web app inside. And then because of that native container, you get this, you can access cross-domain data. So talking about CORS. So CORS is a standard implementation where you need to have access to the server. So whenever you are accessing the data should come with the header which says access control allow origin. So if you get this header, the web app will be able to access that data. And then in the jQuery support object, you have .ajax property, .CORS property to check whether it is supported or not. Okay. So the last one is how to use HTML5 advanced APIs in all screens. And what are polyfills and shims? So HTML5 definitely has a big potential, lot of advanced APIs, but it might not be available for all the browsers. So how to develop your app using those APIs and how to fall back? Like I was showing you a fallback plan for all 6 of them. So what is the fallback plan for this HTML5 advanced APIs? So that the answer to that question is polyfills and shims. And the exciting thing about polyfills and shims is there is a session just after my session which discusses about that in much more details. And I encourage you to not miss that session at all. So what you do is, this is your fallback plan. You start with HTML5 API. If that is not available, you fall back to polyfills and shims. And that's exactly what they are. They are the fallback APIs for those HTML5 APIs which are not implemented. Basically, it is generated by different users. Polyfills are the ones which follow the standard API. Shims are the one which is user-generated unique APIs with some standard functionality. And then, of course, your JavaScript code is the final fallback for everything, I think. So, so this is basically the polyfills and shim. I'm not going to talk any more than this. With that, I'm going to show you a demo of this jQuery object as well as a modernizer object in some of these browsers. So this is the feature detection of using modernizer as well as jQuery support object. So you see, you have like a lot of oranges. M4A, maybe. Wave file is probably. Web media OGG is no. So you can see what are the features which are in green are available on this particular browser. WebGL is not. Touch is not in the computer. Fixed position is not. So let's go to another browser. Okay. So here we have a WebKit based browser, and then another WebKit based browser, and then you see some green, some red, some yellow. So my point here is this is I9. So you have some of the features available, some not, but after this session you have the fallback plan, so you have nothing to worry. And of course Opera. So again, the whole point of this is you have this feature detection capability using this modernizer as well as jQuery support object, which not only tells you all the tags which are available, but also the APIs, the cross-domain request objects, styles, animation, SVG, everything. So before starting your application, this is the first thing you should do. Let me show you in an iPad how this looks like. Is there a way to move this to iPad? Okay. So nothing extraordinary, just to give you a starting point for your development needs. And here is another of the device, the Nokia N9, the incredible N9. Okay, so we have a lot of these APIs. So basically, whenever you are developing, you have this fantastic feature detection, which fallbacks, and I also have a Google TV in which I tested the same. So I would like to show you that. This is still okay, so so what I'm trying to, my point here is you don't have to worry about what is the browser, what is the device anymore. What you can do is just start, your first step should be detecting all these features, and then based on the features, you implement your functionality, and then you fall back based on the feature which is available or not. And then the second thing I wanted to show you was the layout. So let me go back to this guy. But let me just show you here if I have that. So this is one of the website, university website, which is using those layout, adaptive layout, and it's really very interesting how it displays on a TV, and I'll show you on the device. This is all based on media query, and this device. So all the media queries which I discussed in one of the slides. Try to see. Okay. So can you see? Okay. Okay. So the point here is I don't have to go to a different page. You know, I'm not going to like mobile.university.com or lancasteruniversity.iapp or something like that. I'm just going to the same website, and I think this is the right way of doing things. The moment you create like multiple apps for multiple devices, in the long run you have to invest much more effort and much more time for that. So see, the whole layout is adjusted based on the media query, and the content is the same. So the only change is in the style sheet based on the media query, and this also works with the landscape mode. So you have this. Can you guys see that? Okay. Remove my monster from there. Okay, so that's fine. All right, that's it. And can we get back to the slide? Okay. Okay, so I want to give you some of these resources, W3C. So you can go to these working groups, learn about what is the standards for mobile development, media queries, audio browser, and some other resources related to Modernizer, jQuery, media queries. And with that, I want to end this with this quote by William Gibson. It's just not very evenly distributed, and I think it's very appropriate for HTML5. So with that, thank you very much. I'm open for any questions. All right, thank you very much.